Hey everyone, welcome back. In this lecture, we're going to be going over subclassing. So let's look at our person and student example right here. Let me just get rid of all of this. So the way we have things set up, we have this class called person, and then we also have this class called student. So let's imagine a real world problem where we have a school, and in this school we have teachers and we have students. Okay, so let's say that each teacher, let's say that we line up every teacher, and let's say that we line up every student, and we're going to go along this line of students and teachers, and we're going to ask each of these people basically to say something. So the students are going to say, oh, okay, I belong to school A, and my name is whatever. And then the teacher is going to do the same thing, except the teacher is going to say, I am a teacher. So the behaviors are very similar, but there are slight modifications for each type. So let's get rid of some of this stuff. Let's look at how to do it without using subclassing. So let's give each student is going to have a name, right? So we're going to create a name variable, and let's make this variable private. If you remember from our last video, we want to use encapsulation. We want to make sure that stuff outside of the student class can't access any of these variables without our say-so, without basically our saying how they should be accessed. So we'll give each student a name, and let's give each student a birth date. So we'll work, just for the sake of simplicity, we'll use a string to store the birth date. Alrighty. So now our constructor is going to take in a name and student name, and it'll take in a birth date. Oops. Alright, fair enough. What am I doing? Student. Alright, so this is our constructor. Alright, now what we're going to do is we're going to assign name to student name, and we're going to assign our instance variable named birth date to this variable right here, student birth date. Student birth date. Alright, so if you've been following these lectures, you've noticed that I've made it a point to name these parameters different from the name of my instance variables. So for example, we have the name parameter here, but we're referring to it by student name. We could do something like this. We could name, this variable or this parameter named like name. The problem is when we do this, Java doesn't know which name we're referring to. Are we referring to this global kind of instance variable up here, or are we referring to this name parameter that we're passing in? So what it does is we're getting a compiler warning basically that says, what does it say here? Show me what you say. Okay, well, yeah, right here. So the assignment to variable name has no effect. What's happening is that it's looking at the innermost scope. So it's looking at the stuff inside of these braces first. So it goes inside of these braces and it finds the name variable. Okay, well, the name variable is this name variable here, and then it tries to assign it to the value of name, which is, again, this same name variable. So we're assigning the same thing to the name variable. If we were to name it differently, however, now what happens is we go to our instance variable, that's the only thing inside of this class called name, and we assign it to the value of our parameter called student name. So that's why we name these two things differently. Now, if you've ever worked with maybe like C++, you might be familiar with something called the this keyword, this.name. If you haven't, don't worry about this, but you can also, if you really want to, you could do something like this. This.name equals name. What the this keyword does is it makes sure that the variable you're referring to is an instance variable basically. So this.name, it makes sure that you're referring to the instance variable called name and not this parameter called name. Alrighty. So let me just get rid of that for now. We're going to go into more detail about this in a couple videos down the road. Anyway, so we have our constructor, and let's make it public. So we have our constructor, now anyone can call it. Now what we're going to do is we're going to make a method called printinfo. And inside of this printinfo, we're going to just do something very simple. We're going to be like, I am a student. and then on here, actually we'll do it like this. I am a student and I was born on birth date. Okay, cool. So that's fairly straightforward. And just to test this out really quickly, let's get rid of this right here. Get rid of these guys. Oops. And we'll create a student object. Student my student, and we'll do student1 is equal to new student, and this student is going to be called Willie, and he was born on April the 20th. We'll just do it like this, 2000. He's a very young boy. And then we can just do student1 dot print info. So what we're doing is we're calling the print info method or function on the student1 object. So we're going to go inside of here and we pull out this function, and we call it, and we do whatever is inside of there. And now we run, and we get I am a student and I was born on April 20th, 2000. Okay, cool. Now let's do the same thing for a teacher. We're going to create a class called teacher, so we'll just do that. Now each teacher has a name, and each teacher also has a birth date, same as the student. And then we're going to have a public constructor that takes in a name and then a birth date. And then we do the same thing where name is equal to mName and birth date is equal to m birth date. And I forgot my string type qualifier right there. And then we'll have another function called print info. And this time we're going to say that I am an almighty teacher. You will not pass. So this is what the teacher is going to say. And then we're also going to print out a second line. I was born on, or what did we do for the student actually here? We're going to take this line, we're just going to copy it. I am a teacher and I was born on birthday. Okay, and now we can do the same thing. We'll just create a teacher1 is equal to new teacher, and then let's give the teacher name Sally. And then Sally was born, she was born in March 19th of 1980. And then we can do teacher1.print info. Alright, and we get what we want. Now this approach has two main problems. One is the issue of code duplication. So notice that we have the same instance variables in both the student and the teacher class, and this print info thing, it does the same thing basically. It prints out that I'm a teacher, and in this case it prints out that I'm a student. And this constructor, it also does the same thing. We're just assigning values to our instance variables the same way. We know that each student and each teacher share two qualities. They share a name and a birth date. So would it not make sense to have some kind of other class, maybe like a person class, that contains this name and birth date information, and then each student and teacher just pull from that information? So this is a little abstract, but maybe you can think about it like if you've ever, like a tree, right? So a tree, it has one maybe like leaf at the top, and then two leaves branch out from that basically root, right? And those two leaves, you can think about, they're sharing the same properties as their root leaves. So actually, let's just implement it and abstract. I think it'll make a lot more sense if we kind of veer away from that abstract stuff. So how about, what if we did this? Let's move our name and birth date variables to this person class. And now what we're going to do is we're going to create a constructor, person name, and then string person birth date. Okay, so we've created our constructor, and now we're just going to do name is equal to person name and birth date is equal to person birth date. And then we'll have something we'll have the same function, right? We'll have this public void print info function. And what we're going to do now is we're just going to print out println IMA, and we're going to leave this spot blank for just a bit because I want to show you guys. We're going to leave the spot blank for just a little bit because this spot, it changes depending on whether you're a teacher or a student. And inside of this class called person, we don't really know what kind of person we're working with. We just know that we have a person. I guess we could just say I am a person. And I was born on birth date. Alright. Now, what we can do now is we can extend person class. So now when we do that, we still need to provide a constructor because the person constructor requires two different parameters. So if we extend person, let me explain what this means actually first. When we extend person, what we're saying is that we want to create a class that's very, very similar to this person class. In fact, it's so similar that every student is going to have a name and a birth date instance variable. Every student is going to have a name and a birth date instance variable. So it would make sense that if, every student is a person, but the thing is, every student has a couple, maybe has some more properties. Every student has like a GPA, for example. Every student has an expected time for graduation. Every student has a school that they belong to. But not every person is a student. You can have, for example, lawyers or scientists. These guys aren't students, so we can't. So the relationship isn't two-way. What we're doing is we're pulling all of the information from person and we're putting it inside student. Okay, so now when we want to construct student, let's say that we create a student constructor. Why doesn't this work? Well, let me put this line right here. Okay, so why doesn't this work actually? Well, this doesn't work because in order to create a person object, we need to provide a name and birth date. But what we're saying here is that, we want to create a student, but in order to create a student, we need to create a person because every student is a person. So we need to populate that information inside person. In order to do that, we have to do something we have to call the super constructor. So why aren't we getting the compiler error anymore? Well, it's because we're creating the student object, and we're also creating the person object with this line right here, line 5. We're creating the person object because what this is doing, line 5, is it's super calls this person constructor and passes in this person name and person birth date. Once we've done that, we've populated this information right here, and now we can access it in our student class. Okay, so here where the name and date are kind of off, they're not correct, so we need to pass them in. String student name, string student birth date. So we need to pass them in, and then once we pass them in, we can pass them into our super constructor. Now, this is kind of still useless, right? Let's say that we want to store the GPA of a student. Well, okay, fine. We want to store the GPA, so we'll just pass it to the superclass. No, this doesn't work. Remember, the superclass is a person, and the person class only cares about, the person class's constructor at least, only cares about the person name and person date. It only has 2 parameters. And so we can store that information in the superclass, but we can't store, this GPA in the superclass. Instead, what we do is we extend the class by adding our own fields. So now the student contains everything that is to know about a person. It contains the name and birth date about the person, but it also contains a GPA. Okay, so that was a lot to take in. Let's create a student just to ground this discussion. Student is equal to new student. Alright, so now what we're going to do is we're going to pass in a student name, same as before, Willie, and this student was born on April 20th, 2000, and let's say that Willie has a 4.0 GPA. Okay, now, Why? Something interesting happens here. We're allowed to call this print_info function or method on the student object. But where is the function? Where's print_info? Well, it turns out that besides fields, besides variables, we're also inheriting functions. We're also inheriting this print_info function. So every subclass of person also contains this print_info function. Now, why is this useful? Well, this is useful because we can do something called overriding. Public void print_info. Actually, let's not override it for 1 second, and let's see what happens when we run this. Well, if we were to run this, we see this output: I am a person and I was born on April 20th, 2000. Okay, that's fair enough, but we want to say that I am a student, not just a person. Well, in order to do that, we override it. And what this does is it customizes the behavior of the function declared in the superclass. So let's run this. We run this and we don't get anything. We don't get any output because what we've done in essence is taken the print_info function and made it empty, made it so it doesn't do anything. See, I'm in the student class now. But if we were to run this, now we see this output. What we've done is we've taken the print_info function, we've emptied it, and now we've added our own custom kind of function information. To further demonstrate this, let's create a person. Person1 is equal to new person. So this person is just going to be called Joey, and this person, all we're storing about this person is the name and birth date. We're not storing any GPA because this person isn't a student. Remember, every student is a person, but not every person is a student. Print_info. Okay, so before I run this, think about what's going to happen. Up here, when we print info, we go inside this function and we just print out this statement saying, see, I'm in the student class now. But what are we going to print out when we call this print_info function? Are we going to print out this right here? This line right here where that says ICM student, or are we going to print out this where it says I am a person and I was born on? All right, 1, 2, 3. I'm going to run now, and we get I am a person and I was born. What's happening here is that we're just going inside the default person class. So we go inside the person class and we're just printing this out. The only reason we're printing something different out when we call it on the student class is because we've overridden the function. We've overridden the function so that we've customized its behavior. Also, just a quick side note, whenever you're overriding a function, it's generally good practice to include this thing called an annotation up here. This annotation at override, it indicates that you're actually overriding a function. And for example, if I were to do this, suppose I thought that print_info with an E was overriding a function. Well, there is no such function inside of here, so we're not overriding it. If we were to do this, then we get a compiler error because we have this at override annotation. This at override annotation indicates that this function below needs to override something inside the person class, and if it doesn't, then we need to get some kind of error. If we were to get rid of that at override annotation, we wouldn't get any compiler error because basically the compiler thinks we're creating a new function. It thinks we're creating a function called print_info, when our true intention is to actually override the behavior of the person class. So, just a general rule of thumb, whenever you're overriding a function, always include this at override annotation. Alright, in the next video, I'm running out of time here, but in the next video we're going to go into more detail about basically customizing. We need to actually populate the teacher class. That's what we're going to do in the next video, and that'll help us understand a little bit more about polymorphism and subclassing. Alright, see you guys then.